Coming up on this episode of the IoT Inc Business Show.
Yeah, and I think in particular, making sure that you have a software ecosystem that can support the different hardware, communication interfaces, applications you want to create. And as much as possible, I think what you're going to see happening is that a lot of budget used to go into kind of hand piecing together the proprietary software. That's going to change.
In broad strokes, the software required for an IoT deployment can be grouped into 4 classes. Embedded software for sensors and gateways, networking or the IoT platform, data management and analytics, and of course the IoT application. In this episode of the IoT Inc Business Show, I discuss sensor operating systems with Zach Shelby and the inevitable evolution of these disparate classes into an IoT software ecosystem.
All this and more on this episode of the IoT Inc Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc Business Show. This show is made possible by sales of my book, IoT Inc, published by McGraw-Hill, and the IoT Inc Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 6 is Zach Shelby. Zach is VP of Marketing for Internet of Things at ARM. But don't let that fool you. He's a serious techie at heart. He's worked on IoT standards, co-founded the startup Sensinode, where he acted as CEO and CTO, and he's co-authored a book on 6LoWPAN with my friend Carsten Borman. Given his work at the IETF, IPSO, and now Thread, plus his experience at an embedded software sensor startup, I thought he'd be able to provide a great perspective on the software found in the connected sensor. Zach, welcome to the show.
Thank you, Bruce.
So what have you been up to? I understand you've been doing a little bit of traveling lately.
Absolutely. We are all over the world at events telling people about standards, about software ecosystems for internet-connected things. And we're happy to do that.
All over the world. So I did not know the new title, VP of Marketing. So you're kind of an evangelist, or what are you doing right now at ARM? Tell us a little bit about your role there.
Sure. So I think evangelist techie would be the right term for me, or evangelist nerd. At ARM, I'm really all about letting people know about the great software tools, implementations of standards that we have available for people making embedded products.
Oh man, you sound like a marketing guy.
Exactly. But at the same time, we're creating great technology. And so for me, marketing is really about helping get the technology to people, teaching people about standards, how they work, how technology works, right? How software works.
Right.
And I think that's really exciting for me, is the teaching side of it.
Yeah, no, I agree. And I mean, at its heart, marketing is all about communication, and teaching, I should say, is all about good communication. So I'm with you there. Well, tell our audience a little bit about yourself and your background in IoT. I gave a little bit of a blurb, but I think there's a little bit more to the story.
Yeah, so I started in the wireless, internet connected, low power embedded device space back in the late 90s. When it was really still kind of the internet web bubble, we could maybe call it at this point.
Okay.
But the huge growth in the web, right? And that was the important part. The web became a platform for innovation. We were looking at, well, if the internet's so powerful, we can do a lot of interesting things. Why can't we do the same with low power devices, small embedded cheap devices over, wireless mesh networks? Why can't those be part of the internet? Why can't we use the web Yeah, why can't we do security end to end? We were asking ourselves those questions in the late 90s, and started working on a whole string of really interesting projects in the research world at that time, where I started out, really pushing the envelope. Why can't we do IPv6 over a little sensor network? Why not? Why can't we do the web? What do we have to do to make it work, right? It wasn't about, oh, it doesn't work, so let's create something completely different. It was about, how do we make it work? And we did the wrong things. We did the right things. We learned a lot in, say, the early 2000s about what we can do to really make an Internet of Things come true.
Now, was this in the context of research, as you were saying, research lab, or was it commercial at that point?
Research lab. So up till about 2005, I was involved with a couple different research labs. Led some teams doing everything from ultra wideband wireless communication technology, including positioning, to we did some of the first software stacks running IP over what became Bluetooth Low Energy. Interestingly enough.
No kidding. Okay, and that just seems to be a recent event, at least that's been kind of brought to the public side.
And
anyway.
what a lot of people don't know is that actually started back already in 2001 in Nokia laboratories in Finland. Actually started working on what later became Bluetooth Low Energy through a couple different names.
No kidding.
So we were involved in some of the early days of wireless standards like that. And at some point we realized that to really make this technology come off, get the standards that we've been working on out there, we wanted to make it happen faster. And we founded a startup to do that. And that's how SenseNode was really born. We had the vision of internet and web everywhere, and we wanted to do it through open source, through getting the technology to people rather than waiting for the big corporations of those days to just take it and use it.
Now, what was SenseNode's? What was its main focus then? So, what was the product? I guess I should say.
Yeah. So at SenseNode, we actually did two things. We provided some of the first 6LoWPAN stacks on the market, and using an open source model to start with, and then going into stack bundling with silicon partners. So we actually worked with Texas Instruments, with Atmel, to get the stacks in the chips right out of the box. The other thing we did is we then said, well, that's nice. We got internet to people. Well, what do you do with just the internet protocol? Ping, right? Trace route. That's nice, but
somewhat interesting.
Yeah, it's nerdy. But what we found is that when people went and tried to build a real product, a system, they ended up reinventing a binary UDP-based protocol each and every time, right? And everybody did differently.
Okay.
So we started looking at, well, what does it take to really let us do the web over these networks? What's the ideal way to use the REST architecture for moving data around? Should the device be a client or should it be a server? How should we represent data, right? How do we deal with security? Do we have to do something completely different, or can we adapt something like DTLS? And so we really dug in and looked at all those questions and ended up creating a server-side software product as well that helped us access all the protocols and security that we needed to go and do that. And in the process, we helped create a bunch of new standards. The most notable being COAP, the Constrained Application Protocol, actually came out of that work that we did on, hey, how do we do web over 6LoWPAN? And COAP ended up being the answer when we worked with a whole bunch of other people in standardization.
Are you still involved in COAP? I mean, we've had a number of presenters at my conference, and even on this show, we're going to have a show with Michael Richardson in one or two from now. What's the current standard with COAP?
Yeah, we'll say
standard. I should say, what's the current situation?
Say hi to Michael. So I am deeply involved with the IETF still. As I said, marketing nerd.
Yeah.
So I do. I'm writing a couple standards right now in the working group where we standardized COAP.
Oh, good.
So there's new things going on. We're doing COAP over TCP. We're doing something called a resource directory, and then recommendations about how to create REST resources. So if you do create REST resources, what's the style to do that, right? What's some guidelines? So we're writing RFCs on those subjects. I also chair a working group on optimizing DTLS for security, which is something really important. So how do we really create interoperable security, but make it as simple as possible for things? And we're updating standards like 6LoWPAN, right? Doing what's needed to support new standardization efforts like Thread, which really, it's more like Wi-Fi, right? It puts together the different IETF standards you need to go make an interoperable system.
Well, that's what I wanted to talk to you a little bit about, and maybe we're jumping ahead, but I think it's an opportune time. So I know you've also had the history with IPSO, just with the IPv6. We're talking about 6LoWPAN and CoAP, both dear and near to my heart. Now, how does this all tie together, or what's the differences between the work you're doing on the standards bodies and Thread? And in fact, we are going to actually have a separate show with Thread and the different alliances, groups, and consortiums. But from your perspective, what is the differences, and what's the different work that has to be done, and what are the different roles of these different organizations you're involved in regarding, the Internet of Things, and specifically this IPv6 thread through it?
So there's a really simple way to look at this. The Internet Engineering Task Force, which is really a body of volunteers, right? We go there and we really throw our heart and energy into, creating open standards for the Internet of Things. Most of us involved in the IETF would go there on our own dime, on our own time, right? And still participate. Yeah. And I would as well, if I wouldn't be doing what I'm doing now. Absolutely. And it doesn't market, it doesn't advertise what it's doing, which is an interesting thing. So the IETF's an open organization, of course, makes all the information available, but it doesn't really have a marketing budget. It doesn't go and tell people about, hey, look at 6LoWPAN and CoAP, and these RFCs are so great. Go use them. They're not advertising, etc. They're not certifying that you have used RFC, 2556 correctly. The IETF doesn't do that. So that leaves a role for other organizations to help market Internet standards. And a great example of that is the IPSO Alliance. So the IPSO Alliance was actually formed. We formed that with partners like Cisco and Ericsson some 5 years ago. And the reason we did that was exactly this, to help market and tell people and teach people about the Internet in the things space, right? How does it work? How do the standards come together? And that's been really successful. We've actually done a lot to teach the industry why Internet-based standards are great. And in addition to that, you also need alliances to help do more vertical integrated stacks of IETF standards. Okay. So IETF standards tend to be very piecemeal. They have UDP, and you have TCP, you have CoAP, you have 6LoWPAN, and those are separate specs. You can mix them all together, and that's just how Internet layering works, right? You can use different combinations of protocols, and that's okay. The Internet was designed for that.
And theoretically, they should all kind of fit together and work just nicely.
Right, except when you go into an environment like a home, right, and you have a Wi-Fi connected sensor or 6LoWPAN connected sensor with a consumer, how is that going to work? How do we know that these things are all configured to work with each other using the right versions of standards, et cetera? Okay. And that's where an alliance can actually help put together for a specific use case. Let's take smart home, for example. Actually make sure that the right version of 6LoWPAN with routing and security are used. They're all set up in the same way, right? You deal with network joining in the same way. You have the same basic requirements for certification so that the products work with each other. And that's what Thread's all about, right? Thread's about taking those pieces of IETF standards and specifying how they need to work with each other so that you can really do consumer products out of the box.
Got it.
Not all that different from Wi-Fi, right? Wi-Fi has a similar role in the industry.
You mean the alliance?
Yep.
Yeah. Well, let's close the loop on you. The transition to ARM. I guess you've kind of indirectly said what you're doing. You're going out there. You're still working in the standards bodies. You're evangelizing. How's the transition been from a startup to such a large company?
Exciting, really. One thing to keep in mind is ARM's a medium-sized company. We're 3,300 people located around the world.
I thought it was bigger. Okay.
Yeah, but the impact we have on the industry is huge. It's really exciting to be in that position. I think the biggest transition going from a startup to a larger company is that we have the resources to completely transform an industry. With a startup, you can make your vision happen in the way that you actually can implement it. You can get it to some customers. You can go tell people about it, and you can do it fast, right? You're agile. You can go move, and you can change things. And everybody says that it's never going to work, right? Or this is never going to happen. You can say, no, it will, and I'll make it happen, right?
Right.
But you get to a point with a startup where when it's time to really go take that technology and scale it across an entire industry, you don't have the resources to do it. You can't expand fast enough. You can't give something away when you should, right? In order to make money maybe later on.
Sure.
Because in startups, you oftentimes have to show that you're actually making revenue.
Sure.
So the coolest thing about taking that technology that we created at SensiNode is that at ARM, we can come and give it away. We can do open source. We can make it scale across, hundreds of thousands of developers very quickly and really get that technology out there. So it's really about making the cool technology we did as a startup scale. And that's what we're seeing happen right now. We went and launched a new operating system and software ecosystem for IoT called Embed, where we actually are integrating all the SensiNode technology.
So SensiNode is it no longer called SensiNode? Now it's Embed, or is it two different things?
No, it's actually we've integrated all the SensiNode technology into Embed, so we don't have any of the old SensiNode brands aren't around anymore. Everything's part of Embed.
And how long has it been now? The acquisition?
Year and a half.
18 months, baby. Okay.
Yeah.
Well, let us know. What's one interesting fact that most people don't know about you?
So I'm actually very much an outdoors and kind of handicrafts type of person in my spare time. So when I'm not working with technology and going out and evangelizing what we do, I'm skiing in the backcountry, hiking, and I do a lot of woodworks. So actually building furniture,
nice,
things like that. So kind of a handicrafts kind of guy. And one thing that a lot of people don't know about me is actually my first company before doing SensiNode was actually an outdoor climbing and backcountry skiing. I still own that, and it's still running, which is pretty interesting. So,
is that in Finland?
That's in Finland, yeah.
And so you mentioned before the call that you're there now. Is that what you're spending your time on, in the backcountry, hiking and
skiing as much as possible? Yeah.
Well, in California, at least we're getting a little bit of rain this year, so there's a bit of skiing, but it's nothing like Finland, I'm sure.
Yep.
All right. Well, let's get to business here a little bit. Can you describe for us at a high level what's the software that's needed in a sensor or a low-powered IoT device? What are different components? Just give us an overview of that.
Sure. So if you look at the microcontroller space, right? We'll just leave out bigger processors where we have full-on operating systems. But the microcontroller space, you have a few different levels of software that you can work with. You can do what we call as bare metal. So you set up your drivers. They might come with the device that you've got from a silicon vendor, or it might be part of a project that you use. So drivers are a starting point. And then you may do your own software, take in some communication standards that you need from various places, integrate it, and basically write your own main loop. And it's really just the basic level of engineering that a lot of really simple embedded products actually use today. So bare metal driver-based embedded devices are out there.
Okay.
Now that works for a small set of functionality. You can only do so much with that and maintain it. It gets difficult to maintain at some point. So the smaller end of microcontrollers tend to use this. Another level of software for devices are what we call low power operating systems. So where the goal is to get as much software functionality in the device as we can in a standard package, reusable software. But the goal of the operating system is not to do things like real-time scheduling and control, but really just to optimize power. How can we get these different functions working in a way that we're at the lowest possible power consumption, where we're using resources efficiently, we're not using more flash and RAM than we have to. Mm-hmm. We don't require as much clock speed. And that's another class of operating system.
So power is the fundamental driving factor in that case.
And functionality.
The power consumption.
Yeah.
And functionality.
Power and getting just the standards.
Balancing the two. Okay.
Yeah, the different functions you need that you have reuse, right? That's the two major things. And then we have a third class of software for microcontrollers, and that's what people know as a real-time operating system. Okay. And real-time operating systems aren't really how we think about operating systems in the PC world, for example. They're really just scheduler kernels. So it's the scheduling part of an operating system.
Of an OS.
So if you look at Linux, for example, that would be the Linux scheduler that gives you your process sharing. And those are really specialized in real-time control applications, safety applications, and you do things like preemptive scheduling, where you can really make sure you've got hard time limits on how long different pieces of the software can work, or how fast you have to meet a deadline for control. And those tend to be very specialized. So you have different sets of software that come with for different industries. You might have some specialized in automotive, some in more industrial applications. And so it's a really, really fascinating class of software because it really runs a lot of the hard industrial applications we have. It runs, trains and it runs aircrafts and a lot of really exciting things that run on real-time.
Planes, trains, and automobiles.
Absolutely, yep. One of some of the main applications of real-time operating systems. And it's getting exciting in this space today. And I think that's the cool thing about the embedded electronics and software space is that we really start to have more and more software available. And I think it's only going to get better. In the real-time operating system space, we already have a lot of really mature options. Everything from open source real-time software like FreeRTOS to commercially supported source code from, for example, Micrium or ExpressLogic. Great examples. You can get commercial software, but you get the source code, you can compile it, you get support. And at ARM we work with all of these RTOS partners, and making sure that all the support's great, drivers, etc. So we do a very wide range of microcontroller technology.
So what were the open source or the non-commercial drivers you're mentioning?
So a great example for open source is FreeRTOS. So FreeRTOS is one of the better known open source real-time operating systems.
Okay. And what about TinyOS? Is that fall in that classification as well, or Contiki, or where do they fall into the spectrum?
Very good question. So that's not the real-time operating system spectrum. That's that middle one, this low-power operating system with functionality. So TinyOS and Contiki are both great examples of kind of free community open source based projects with the roots back in academia. Now, just recently from ARM, we actually announced what we call Mbed operating system, Mbed OS.
Right.
And that falls in that category as well. So that's
it does. Okay.
Aimed at not real time, but the really low power devices where we're focused on internet connectivity and security in particular. So
what do we call these? Low power? No, they're not OSs. You said so. They're what are we going to call these? Number two there.
When things settle down and when you look back in time, let's say we look back 5 years from now, we're going to call these things operating systems.
Okay.
As simply as that, right? It's just going to be an operating system, and we're not going to think deeper into it. It's going to be the whole set of software, from drivers to scheduling to security to communications, that you need to go start creating your application, right?
Yeah, no, I'm talking about the middle. So we got the bare metal. You're writing your own drivers, your main control loop. Okay, I'll call that the bare metal software.
Yep.
The second one is for energy management, balancing energy management and functionality. And the third one is the RTOS, and I'm sure it's evolving from there. But what's that second one? What do we call those? I mean, so Contiki is one of those, and TinyOS is one of those. What do they have, like a generalized name? I know they fall all under the the OS umbrella, but for that middle segment, because I think that's important.
I think we'll really end up just calling them operating systems.
All right.
Simple as that. Operating systems for embedded devices, or for IoT.
As opposed to the RTOS, is it contrasting it to the RTOS, which are more specialized in particular verticals and often, unfortunately, having the silos they carry around with them?
Well, I think that really will be the difference, right? We have the operating system where you have all the software you need, works for most things, internet connected devices in particular, and then you have real-time operating systems, which are exactly that, right? It's a software stack specialized in real-time performance, and you'll naturally have this application to different verticals like automotive or safety applications. And so I think that is how people will talk about it in the future.
Okay,
absolutely.
Now, so if we squint a little bit, we can see with Moore's law and with everything else that the hardware is obviously getting more powerful. There's more memory available, and it's becoming lower cost. So I think, as we've seen in general computing, we're seeing prices going down and we're seeing capabilities going up. So I guess my question is, when does the general OS, or will the general OS ever be able to I guess, consume or eat the RTOS? And, my perspective, and I've said it many times, is all about standardization. And I really believe one of the greatest frictions that are holding back IoT today is this lack of standardization at multiple levels, specifically at the at the IP level. Mm-hmm. But I see RTOS, if we're talking about certain IoT applications, it's really important that that RT part of the RTOS. Is it going to be subsumed or consumed by a general OS, or is there always going to be a place in IoT for real-time operating systems?
So I think there will be a place. I don't believe that the real-time scheduler operating systems will be consumed by a general operating system. I think what you'll find is that they'll start to work together at some point, and we're already starting to see that, right? Like at ARM, for example, we collaborate with RTOS vendors and provide them with parts of the technology we have. We have something called a client, which does all the upper layer standards for communications, from security to CoAP, HTTP, device management. And we actually bundle that so that it can be used on RTOSes and on Linux, for example, where you have another operating system. So you think you'll start to see these kind of combinations. But we've seen it also in the Linux space, right? In Linux, we have not only basic Linux, we also have real-time variations of Linux,
right? Where
you can add on a special scheduler to Linux. It's not used very widely, but it is used in certain applications.
In IoT?
Not so much in IoT, but more in really hardcore industrial control applications. You'll see kind of industrial PCs running real-time Linux. And so I think you'll see a similar trend happen in the microcontroller space, where you'll have a general operating system like EmbedOS, and then the ability to plug in some real-time things when you need that.
Yeah, and I'm okay with that, as long as, and I don't know if when you were talking about the upper layers, if you're talking about the communication stack, but as long as there is, a common communication stack, or I should say a communication stack that uses standards, and so that we can then, start leveraging the economies of scale, whether it's an RTOS-based system, whether it's a general OS, whether it's, well, I guess not bare to the metal, although maybe some of the drivers, but is that what you're talking about? Is that possible?
It is, and that's where we're going right now. I think that's the big trend we're going to see in 2015. last year was all about, we gotta get the standards. Where are the standards? When IoT hype was really on the upswing, right? And the answer I've had for a lot of people when I go to talk to them is that, we've got the standards, right? We've been working on this for 10 years. We've got low power IPv6. We've got, a really efficient binary web protocol. We've got security. We've got discovery. We now have object formats. The IPSO Alliance recently published a whole set of object semantic formats, really nice and reusable. We've got device management from lightweight M2M in OMA, all open standards based on, basic internet building blocks. We have them. Let's go out and use them. So I think last year we really got that message through to people. We've seen alliances come together that really putting those pieces together. And, OIC is an example of that, kind of putting all the building blocks together and say, hey, here's different architectures where you can use internet standards. And I think that's a healthy thing to do. Now, the challenge this year is how do we get those standards to people, right?
Okay.
Now, traditionally, embedded software hasn't worked like that, right? Embedded software has been more like, hey, here's a chip and here's some drivers.
Use it.
You need to go and put together the pieces of your thing, and we're assuming your thing's really specialized. So the same package of building blocks won't work for everyone.
Right.
And so it's been very fragmented. You've had to go and piece together a security stack here, a Zigbee stack here, and that hasn't really provided for scale. So the big trend this year will be software ecosystem. So getting all that software and all those standards implemented in a way that people can get a hold of them. And that's kind of the problem we're trying to solve at ARM now, focusing all our energy on, we've got, we're shipping over 3 billion Cortex-M, that's our term for microcontroller, chips with our partners. Of course, we don't make chips, but Texas Instruments does, Atmel does, NXP, all of our partners. Over 3 billion a year. How do we get all these standards to those chips, right? That's a huge number of devices out there if we could just get the software technology to everyone.
Yeah, and these I guess these software ecosystems are going to be dependent on open standards, obviously, because you have to write to something.
Yep, and you have to get services working with your devices, and that's the other thing that will happen is as we have the software ecosystems available, the standards are easily available to developers. You need that other part of the ecosystem, which is the cloud players, services that can host your data, operators that can go easily, build out a network for you, an infrastructure, server platforms that can talk to your devices, easily make a web page. And that's why, actually, just at the end of last year, we announced that we are expanding our partner program to cover the cloud side of things as well. So we used to only partner with silicon providers and support their chips with the software, make sure all the drivers are great. But we've realized talking to people in the industry, that wasn't enough. We need to actually go work with all the cloud players, including players like Salesforce.com. You wouldn't normally think of, right, as an embedded IoT player, but they are. They're one of the world's largest business application platforms.
Yeah, no, and I think it's an important point that you bring up is, and to a certain extent, what you're really talking about is bridging OT and IT. And so, yeah, we need the cloud to be using the same stacks, the same standards as the chips, as the software, as the protocols, which we've talked about on this show before, and we're going to be speaking about more. And as the as the OSs, as we're talking about now, and obviously being hosted by the chips, because that's what the Internet of Things is. It just goes beyond the operating technology of M2M or these specialized industries that we've talked about before. It goes beyond the enterprise IT, which gathered, I guess, more human-based information or inputted in whatever format, and that's really. I guess that's really important, is that bridging between the OT and the IT. And I guess if you think about it, it makes logical sense that ARM and other players would start thinking about the communication in a more holistic manner. Yep. And so that's what you're seeing this year is, I guess, a broadening of the vision, I guess a more practical use of the standards, of bringing together the standards from these different alliances, groups, consortiums, and then to enable, I guess, a broader vision of what I guess, communication means for IoT. Is that a fair way to summarize it?
Yeah, and getting the software to people, right? So we'll be open sourcing a huge range of communication standards this year through Embed. It's one of our main goals, actually getting technology to developers for free. And the whole sets of technology, right? Not just little pieces of it, but things they can really go use in products.
That's what that's what I wanted to talk about in particular now is, okay, so listeners to this show, we've got all types of listeners to the show, but although we're talking technology now, because I really believe, you have to understand how it works before you can put it to work. Really, the focus here is for business executives, leaders, managers that are thinking about implementing IoT within their business as a process or within a product. So we're going to make our connected product. Now we need to make a lot of different decisions. I've spent, again, the first 5 episodes of this podcast on sensors, in particular, more at a macro level, not at the embedded level. We're going to do that as well. But what do they need to think about? When you're planning your IoT business, what do you need to think about from a software point of view? What are the important factors that you should be taking into consideration when you're building both your business plan and your requirements doc? Because I'm assuming, that's where then we let the serious techies, I guess like yourself, take it from there. But from a business point of view, what do we need to know so that we can talk intelligently, budget intelligently, and make the right strategic decisions when it comes to the software on, I guess we've been talking holistically, but in particular for this episode, I want to talk about the software on that sensor. What are the considerations? What are the factors here?
Well, I think there's a couple of things. First of all, you can't separate the hardware from the software. You have to think of them a little bit more holistically. So first, I think it's really important to choose hardware platforms which have a really long life cycle, because not only are you going to be putting a device out in the field for a long time, you're also going to be evolving the product, right? You might open up new versions of the product, new variations as you succeed. So really important to have scale around the hardware families you have.
Now, but why do you need to separate hardware and software? I mean, from the evolution that we've been talking about, specifically if we're looking at standards and in these ecosystems, theoretically, they should run on whatever hardware you choose, or is that just not the case? Is that not realistic today?
For over-the-air standards, absolutely. So if you're thinking about, for example, interoperability with another device, even from another vendor, could use...
that's what I want. I want different interoperability between different vendors. But so does that mean I have to pick a specific hardware or?
Not at all. So that's definitely doable. And that's something to keep in mind when you're choosing software, is that you have this interoperability, you have the standards for that reason. However, though, when you're making, the hardware decisions within your own organization for your own products,
the business decision in this case,
exactly.
Picking the right hardware that'll last.
Scale, right? You want to be able to reuse the same microcontrollers, families across the same chips. You want to maximize your volumes of hardware that you can actually purchase when you're making that across devices, right? You want to be able to reuse radio interfaces, drivers. So there's a lot you can do with certifying, modules for what you're doing, and then reusing that across products. So I think hardware in that sense is a business choice of how you create scale across your products. I think that's important to keep in mind. Okay. And where that hits software, right, is that, when you're choosing software ecosystem and you're building up your software toolkit, you want to make sure that you can reuse the same software applications across those products, right? You might have 3 different variations of a home automation sensor, for example. You definitely don't want to have 3 completely different software toolkits. You want to have the same one, and you may have 3 different variations of an application, right?
So is this big decision number 2? First one, picking the proper hardware platform. Second one, picking the proper software ecosystem?
Yeah, and I think in particular, making sure that you have a software ecosystem that can support the different hardware, communication interfaces, applications you want to create. And as much as possible, I think what you're going to see happening is that a lot of budget used to go into kind of hand piecing together lots of proprietary software into it.
Absolutely.
I think that's going to change. I think the budget's going to be more in the hardware making sure you have the best possible hardware and design for your device, right? The importance of design is getting bigger and bigger. Embedded devices are becoming sexy. It never used to be like that, right? Look at the thermostat, right?
That's pretty
Thermostats were
sexy.
never sexy. Now they are. Thanks to Nest, right?
Yeah.
I think you're going to see a lot more of that, right? A lot of energy will go into design, and then the energy won't go into piecing together your crypto libraries for the software. That will just become part of the software ecosystem you chose.
Yeah, but what time frame are we talking about, Zach? I mean, because we've been this year.
It's happening this year. Yeah, it's going to be really exciting. That's what gets me out of bed in the morning, is that this year is going to be super exciting that we can actually get that kind of software to people. So
software ecosystems, that's what I want to talk about. So software ecosystems, now, these are directly related, choosing your software ecosystem, are these directly related to whether you're in the all-scene camp, the thread camp, camp, or how are they delineated, and what are the choices that are available then?
Yeah, no, that doesn't have to do with standards, luckily. That would get really messy if it did. It's not about the standards. Standards are the whole set of things that you need to have in a software ecosystem, right? You need to have implementations of standards. So whether they're, Thread or Wi-Fi or Bluetooth Low Energy or 6LoWPAN in general, all those need to be supported by a software ecosystem, right? It's got to be part of the software toolkit. Yep. Just like those things are supported in Linux, right? Out of the box, you've got Ethernet and Wi-Fi support. TLS security, for example, that's not something that can be an add-on, right? It's got to be part of your operating system, part of your software. All the standards we've talked about need to be part of the software that you use. So when it's about software ecosystem, it's really about finding an easily available software where you have an ecosystem around it. You've got enough people that you work with in your value chain, right? Because now it's not just about you as a company. You probably have to work with other suppliers, module makers, gateway manufacturers, gateway platforms.
Okay.
You need to work with service providers. You need to work with maybe cloud providers, right? Maybe you want to host your application somewhere. So you want to make sure the software ecosystem you're working with actually has those players involved so you can easily go work with them.
So software ecosystems, are these now packaged as products? Is there more than one to choose from? Because I like the evolution. I mean, as opposed to having to think about it at a protocol level, at an OS level, and then a different protocol level, usually after the gateway, whatever.
Yep.
Now you're saying, no, you think about it as a software ecosystem. Great. That makes sense to me, logical sense. Now, again, from a business perspective, are there choices out there right now that we can actually make, or, what's the variety out there?
We're just starting to see the evolution of this in embedded, right? We've had it in mobile, right, for a long time. Great example,
Sure.
Android is a software ecosystem in mobile. Absolutely.
Yep.
So is iOS, actually.
Absolutely.
In cloud, we have this. We've had it for a long time. Different pockets of technology that work great together. Software you can go get, toolkits for free, open source. We're just starting to see it. One of the early ones in embedded was Arduino. Arduino is a great example of a software ecosystem.
Sure.
You go get the toolkit, you go use it, you can prototype your stuff really quickly. At ARM, we're big fans of Arduino. That's more aimed at maker kind of prototyping phase of the evolution of a product. Now, what we're going to see this year is the start of software ecosystems for actual products, which used to be, take a piece of software here and there. And that's really what we're focused on with the ARM Embed project, is actually doing that. And that's what we're going to be bringing out this year, is actual complete software ecosystem. So not only the software for free, but also all the partners. So partners making modules, dev boards, gateways, operators who will actually host services for those, back-end software providers that make sure things are compatible. So that whole network of different companies.
No, I dig it, and it makes a lot of sense. But I want to have more than one choice. So, what are is it just that Embed is coming out first? Are there others out there? What's the landscape look like?
So right now, Embed is one of the bigger efforts going on. We've had some software ecosystems from individual silicon vendors for quite a while. So different silicon vendors tend to kind of create their own software toolkits.
All
That's
right.
been out
Okay.
there for quite a while, and you can do
Sure.
a lot with those.
Mm-hmm.
You will see things that are programming language specific. So you have things like Java ME, for example. That's what Oracle does, making sure that Java runs on devices.
So it becomes an
It
ecosystem.
becomes an ecosystem of a kind because it's around a language. Now,
Yeah.
the
Mm-hmm.
line's not so clear though, right? So if you look at Java ME, we actually use Embed OS to run Java ME, right? Because you need a native operating system under something
Sure.
like a Java interpreted language. So they actually work together, right? You may choose what language you write your programs in. So there won't always be that it's one software ecosystem versus another. It may be that one sits on top of another, for example.
Mm-hmm. Mm-hmm. So looking at it again from a business perspective, your recommendation is, okay, start looking at it more at a macro level.
Yep.
Look for, if possible, a software ecosystem that you can buy into that's going to support the different use cases that you have, the different hardware configurations that you have.
Exactly.
What other advice can you give, again, looking at the software decisions that have to be made? Are there any other big ones?
So I think another big thing is that the change you'll see now that we don't have to invest as much in pieces of supporting software, you're going to see a lot more effort put into application. So the application that goes and runs on the device, that's what our designers and the companies we work with, that's what they should be thinking about from day one. How do we make the user experience great, right? How do we make sure that this device has the features that really, fundamentally changes the problem we're trying to solve? If we're making a thermostat or a light bulb, what is it that we need to do to make that great? And focus on that from day one, right? Rather than kind of building up all these nerdy technology. As engineers, we love to solve those problems, but that's not the problem that the consumer has, right?
Okay, so in this case, what you're talking about are the apps for the products, and the products using sensors, and whether distributed or whether built, they're embedded within the product itself. So you're not talking about writing apps on the sensors themselves, or is this just a semantic kind of difference that we're talking about here?
So yeah, you don't actually write sensors on apps on sensors per se. You write apps on the actual microcontroller.
Yeah,
but you have a lot of system on a chip technology being used already now, where the line between these is getting very blurred. We have Cortex-M cores built into all types of sensors. Sometimes it's a single sensor. Sometimes it's a whole range of sensors built into the chip itself. And so you actually have processor plus sensors all in one package.
Okay. And so that'll be enough to run your entire embedded product then, is that what you're saying?
Absolutely. Yep, absolutely. We're seeing, devices easily with tens of kilobytes of RAM, hundreds of kilobytes of flash for very low costs being integrated with sensor socks. That's been happening already for a couple of years now as a trend of integration.
So for the sensors themselves, in the case of, say, measuring a process within retrofitting, I'll say, an existing process, then from a software point of view, again, the recommendation is look at these software ecosystems, and that pretty much covers it. Then is that right? I mean, because that's going to take care of the the operating system, whether it's real time or not. That's going to take care of the communication stack, hopefully with the standards that we've all been talking about.
Security. Take care
and
of
the security.
Yep. And you still have to do a lot of work, right? But then you'll be able to focus your work. For example, you may have a very specialized sensor, right? That's the special thing you do. You might write the driver for that sensor. And then, you might contribute that driver back to the software ecosystem so the ecosystem grows. It's what a lot of the people involved do. Because their job might also be selling that sensor separately.
Right.
And then you focus on the actual functionality of the device. And you can kind of shift your effort around. Now, the other big trend I want to point out is that, and I love this quote, is that from one of the analysts that we work with, is that by 2018, over 50% of the applications in IoT will be from startups. And not just any startups, right? Startups that are only being founded now. So that don't even exist as of last year.
Half.
That's how innovative IoT will be, right? That sounds a lot like the early web to me, right? When web started taking off, huge number of startups totally innovating how we run businesses, how we run, social networks, right? How we solve basic problems of government, right? That didn't exist before. They were founded to go solve those problems. We're going to see a similar trend in innovation in IoT. And I think that's why it's really important that when we build technology, so us as technologists, from tech companies, we need to be building platforms for innovation. Not here's the vertical solution for doing home automation, and you must use it this way, and that's it. More, here's the toolkit of technologies. We've figured out the basic stuff you need to go and communicate, do web communications, etc. Go build what you need to do and do it fast, right? We're not going to do anything that limits what you can create.
Yeah.
And I think that's a paradigm change that we're seeing at the same time embedded, and that's what's driving the software ecosystems, is the need for people to just innovate. Bluetooth Low Energy and Kickstarter right now, you see it. Tons of interesting projects. We see them come across our desks at ARM, and when they use some of the software we do, they tell us about it. We're like, oh, wow, that's cool. I didn't know you could do a new one we saw just recently, a kind of little scale, like a little flat board you put inside your fridge. And you put your different produce and things that you normally have in different places in your fridge, and it tells you when you're out of something.
Okay.
You're running low in the milk department. You usually have this much. Time to go to the store. And I thought it was pretty neat, like just a really simple, hey, I had this problem, I'm going to go solve it type of, Kickstarter type of project.
Yeah. No, I think, I chuckle at that because, I just think back, I guess it was almost a year ago today when the fridges among, other consumer devices were actually set up as a botnet to send out spam. But,
oh yeah.
So I just chuckle on that. It had to happen. But I think your point is an important one. From a business point of view, think about what you're deploying, generalize what you're deploying, not to just solve the problem that you are planning to solve, because specifically, there may be other problems that your platform, we'll call it a platform, can solve.
Sure.
And if you're using something like an ecosystem that's hopefully using standardization, which means that small companies and startups can actually innovate, and that's that 50% number. That's assuming, of course, that this friction that I spoke about earlier is kind of eliminated, and there are some standards, because you're not going to have small startups taking bets on, taking flyers. But the business lesson here is, when you're deploying, you may be doing home automation and maybe it's security, but maybe be a little bit more forethoughting in the sense of the hardware that you choose, but specifically the software you choose, so that you can perhaps offer different products in the future that you didn't even think about, or open up your system for other people to develop on it.
And the network effect, right? Now you have a whole ecosystem without silos of other companies making products. You could bundle theirs. You could sell your product into their offerings in their region. You can find new service providers, operators, to go and sell your product in their markets, all through business relationships rather than through a lot of engineering. And that's really exciting. We're going to see that. It's starting a little bit now. We see some ecosystems of these different vendors working together. But I think in next few years, you'll start to see more and more of that.
Hallelujah, brother. I'm all over it. I appreciate it. Tell our listeners where they can find out more about you, about your company. What some data points that we can put in the show notes.
So I think the best place right now to look for information is at embed.org for what we're working on, all the free software ecosystems I was talking about. So mbed.org. All
right, we'll put that in the show notes. With that, I will say thank you. It was very informative, and I'm hoping like you are that the software ecosystem does take hold this year, 2015. Heard it here first, folks. Zach predicted it, and we'll talk to you soon. So thanks a lot for being on the show.
Thanks, Bruce.
Okay, that was a bit of a deep dive with Zack Shelby of ARM. This podcast goes vertical. deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc, published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc, or the ICIP training and certification program. It's how I pay the bills. Next week's episode is IoT Inc book, Introduction Chapter, read by me. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a logical one.
You have been listening to the IoT Inc Business Show.